Welcome back to Vision Vitals. Today, we're peeling back the lens cap and looking at what makes a speed camera tick, or rather, what makes it click. We're talking about the must-have imaging features that turn a simple camera into a reliable, all-weather high-speed enforcement tool. To help us break it down, we're again joined by our embedded vision expert. Welcome back.
Thanks, great to be here. Yeah, this is a fun one. When people see a speed camera, they just see a box on a pole, but inside it's packed with some intentional imaging tech designed to perform in demanding roadside environments, often running continuously on solar and battery-powered setups where grid power isn't available.
Before we get into what makes a great speed camera, maybe we should talk about what goes wrong when they're not built right. What are the main challenges or shortcomings you see in older or underspecified systems?
Yeah, that's a good place to start. Um, one of the biggest issues is rolling shutter distortion. If the camera uses a rolling shutter sensor, fast-moving cars look warped or skewed. License plates become unreadable, which basically ruins the evidence. Then there's poor low-light performance. At night or in tunnels, images get blurry or too dark, and plate recognition fails. Data loss caused by glare from headlights or highly reflective license plates can also lead to misreads or missed detections, especially in high-speed nighttime conditions. You also see problems if the frame rate is too low. The camera might miss violations entirely in multi-lane traffic. And without onboard image signal processing, you're stuck streaming raw video, which eats bandwidth and adds delay. So yeah, the gaps add up quickly.
So those are real operational risks. How do those challenges actually impact, say, a traffic enforcement agency in the field?
They hurt reliability. If the image isn't clear, you can't issue a ticket with confidence. If the system misses vehicles or misreads plates, violation capture rates drop. And if you're constantly dealing with latency or bandwidth issues, real-time enforcement becomes impossible. Ultimately, the system loses trust, and the whole point of automated enforcement is undermined.
Right, so investing in the right features isn't optional. Let's start with the basics. What's the first thing that separates a high-performance speed camera from, say, a regular security camera?
Honestly, it starts with the shutter. Most consumer cameras use what's called a rolling shutter, where the image is scanned line by line. But for anything moving fast like a car, that creates distortion. The license plate looks bent, the car seems warped. It's just not forensically usable.
So what's the alternative?
Global shutter. It captures the entire frame in one instant, all pixels at exactly the same time. So even if a car is speeding by at highway speeds, the image is crisp. No skew, no smear. It's like freezing motion perfectly, which is absolutely essential for reliable evidence.
And that's feature number one. But what about at night or in a tunnel? How do you keep that clarity when the lighting's poor?
Yeah, that's where strobe support comes in. Basically, the camera can synchronize with a high-intensity flash, just a quick burst that illuminates the scene exactly when the shutter opens. It freezes the motion, cuts through the dark, and makes reflective surfaces like license plates just pop. It turns a challenging low-light shot into a clear, usable image.
Got it. Now, even with a global shutter and a strobe, you still have to worry about exposure time, right? The car's moving and the light's changing.
Exactly. That's why fast shutter time is so critical. We're talking exposure times under a millisecond sometimes. It's all about eliminating motion blur. Even with global shutter, if your exposure is too long, you'll still get blur from the car's movement. A fast shutter speed locks everything in, like hitting pause on a video at the perfect frame.
And I imagine timing is everything. These cameras aren't just taking pictures randomly. They're triggered.
Right. Trigger support for sensor sync is a big one. The camera isn't working alone. It's part of a system. It might get a signal from a radar gun, a LiDAR, or an in-ground loop saying, "Hey, a car just passed here, going this fast." The camera uses that trigger to capture the image at the exact moment of the violation. That synchronization is what ties the visual evidence to the speed data legally and technically.
So the system is talking to itself in real time. What about frame rate? Is it just shooting single shots?
Oh no, far from it. High frame rate is crucial. We're often talking 60 frames per second or more. Why? Because in multi-lane traffic, cars can occlude each other and change lanes quickly. If you only capture one image, you might miss the violation or misidentify the vehicle. Multiple frames give you a sequence. You can track the car, verify the speed, and pick the perfect, unobstructed frame for the evidence packet.
And all of this is happening outdoors 24/7. That brings us to durability, I assume.
Yeah, definitely. Rugged, weatherproof enclosures are non-negotiable. These aren't sitting in an office. They're on poles in rain, snow, dust, and heat. An IP67 rating or higher is common, sealed against water and dust. The housing also has to manage temperature so the sensor and processor stay stable. If the camera fails because of the weather, the whole system fails.
And processing all this image data, where does that happen? Is it all sent to the cloud?
Um, that's a great point. Actually, a key feature is having onboard image signal processing, ISP. Instead of sending raw, high-bandwidth video to a server, the camera itself can adjust exposure, balance white, reduce noise, and optimize the image in real time. That means you send a clean, processed image, not a huge raw stream. It saves bandwidth, reduces latency, and lets the system make faster decisions right at the edge.
Let's not forget resolution. I'm guessing more pixels are better?
High-resolution sensors are the final piece. You need enough pixels to read a license plate clearly from a distance, across several lanes. We're often talking 4K and beyond. High resolution also helps with digital zoom if you need to crop in on a detail without losing clarity. In multi-lane monitoring, that pixel density is what allows one camera to cover a wide area and capture fine details.
So to wrap up, if you're specifying a camera for a speed enforcement system, you're basically looking for global shutter, strobe support, fast shutter time, external trigger capability, high frame rate, efficient low-power operation for solar and battery deployments, a rugged build, onboard ISP, strong evidence packaging support, and high resolution.
That's right, it's a specific recipe. Miss one ingredient and the system's reliability can suffer, especially in the real world, where weather, lighting, and traffic never cooperate.
It's impressive how much specialized engineering goes into something most drivers only notice in a flash. Thank you for walking us through the essential imaging features today.
Anytime. It's tech that does a hard job, and it's fascinating how each feature plays its part.
If you'd like to learn more about speed camera technology or explore imaging solutions for your traffic enforcement projects, you can find more details at Econ Systems' website. And if you're looking for guidance on selecting the right camera module, our experts are here to help. Just write to us at camerasolutions@econsystems.com. Once again, thanks for spending your time with Vision Vitals. We'll see you in the next episode.